And now we have a discussion session. I would like, who else? Who was Stefano, Susanna, Phil, keep going up, Elina, Marek, Lorenzo. Come on. So audience, you have the whole multi-wavelength electromagnetic spectrum and more messengers in front of you right now. Please think of very tough questions and controversial questions to ask them in order to get the fight started. Does anyone have anything you want to say immediately? Does anyone on the panel have anything you want to say?
Perhaps not as the very first question, but I would like to continue the discussion on open data. And I would like to, these collaborations, some of these collaborations strive on having the data proprietary for a long time. So where is the right balance, especially when they encapsulate such a large fraction of the community? Perhaps not the best thing to get started on, but at some point.
It's a good thought.
Maybe, I don't know, maybe everybody can comment, but I can start maybe because I was talking about the open data campaign for the Auger experiment. So we had a long, we are experiment in between the standard particle physics experiments and astrophysics. So the two approaches are differently regarding this problem of releasing data. I think the main reason, at least my personal understanding, is that particle experiments or the data belonging to particle experiments are somehow more complicated to be properly interpreted because they require calibration and the knowledge of the detector, a specific software, and it's not giving a direction in the sky with an energy or with a position, which is mostly, of course, also astrophysics need calibration and whatever, but there is a different approach to data treatment, so to say, and this was somehow preventing in the past releasing data so easily from the particle physics community. Now, we are a little bit in between, so we are trying to move slowly towards releasing a larger and larger fraction of data. This is also required by funding agency, by the way. Most meeting I had the chance to participate, it's somehow also a requirement from the community, from the public society, which makes sense, as we were telling before. It's not easy because also in our case, we have a lot of things that, you can release at different levels, of course. You can release just data points, which we keep doing for a long time already. If you want to release more, you want to release reconstructed variables, you want to release, detector information related to those data. You have to be very careful that people is able of interpreting the data properly, correctly. So it's not, so our effort goes in the direction of let people doing data treatment very well. So having all the instruments to do that well, because it's not easy. Also in our case, we have a large diversity of data. We have atmospheric data, we have calibration data, we have SD data, FD data, radio data. So there is a vast diversity of data. So it's not always easy, simply release them. You really need to take the responsibility of releasing data, which means making people capable of doing themselves the job, which is something more than just giving a table of data.
So am I allowed to disagree with you? You wanted to fight here. Is that okay? Because I'm afraid I fundamentally disagree with that. So, okay, so let me step back and say, I get the point that no one wants people to do bad analysis of their data.
Yes.
However, and I'm speaking as someone who runs a data center, who runs a satellite here, well, I don't run a satellite, you know what I mean. I do not believe that the experiment is or should be the gatekeeper of other people's analysis. What we have a duty to do, so proprietary periods, I'll come back to in a second, but what I believe we have a duty to do is get the data out there, the calibration files and the documentation and the instruction and the training in how to analyze data. People will always do stupid things. I mean, if you've marked a single undergraduate piece of work ever, you will know that no matter how many times you tell somebody what to do, they don't. But, you know, ultimately, good science wins, you know, in the scientific community generally, just by consensus, by the way that the, you know, the way the publication process goes. And I think that the fear of somebody doing a bad job of analyzing my data can hold us back so far, because, you know, there's also the possibility, especially if you've got a big and closed community, that you don't have alternative perspectives on things. I think that, you know, certainly by the end of a mission, you need to give everything out there, because what if in 50 years' time someone finds that something that was a fundamental assumption was wrong? They need to be able to go back and do it again. So my exceptions I would give are, when you've spent, you know, 100 million pounds and 13 years building LIGO, I get the fact that you have a right to say, do you know what's 100 million, a lot more than that. You know, you have the right to say, we need some proprietary time to maximize this. Some of us might argue you've had quite a bit of that now. I have sympathy with especially SWOM and EP and things like that, where they're saying, like, I was speaking to someone from the Chinese community and they were saying, but you guys in the West have got so much experience of doing this now. If we release our data publicly with no proprietary period, then the Westerners will analyze it all before we get a chance. So I get the idea of them saying, hey, we want a bit of a proprietary period, but with limits, you know, 6 months or something, I think is plenty. But ultimately, so what if someone publishes something? If someone publishes something rubbish based on your data, you guys are going to publish what's true based on those data. You're going to be able to argue why it's right, why they're wrong. It's a good education and pedagogical experience. And ultimately, you know, people publish rubbish with good analysis anyway, as you know, if you've ever read a paper, right? So I just think that's a fear that we need to get over, because I think it's blocking. The more open we are, the better the science we get out. At least, you know, that's my view.
Yes.
Sorry. I know if you want to.
I mean, shall I reply now? Okay. No, I mean, I'm not disagreeing completely with you. I mean, I think releasing data once the experiment is done is, of course, the plan of everything. So we are planning to do that once we are done. Of course, the 100% of the data will be released, of course. Releasing the data while the experiment is running, it depends also on the experiment. And I mean, there are things that need some time to be understood. We never are able to publish even standard paper with data coming from a few months earlier, because we need to process everything. We need to understand the detector. We need to understand the atmosphere. We need to understand calibration constant. So it's a long process, as in the particle experiment physics. So it's a little bit different. I think it depends a little bit on the detector. So it's not completely independent of the things you are doing or the detector you are dealing with. But on the long term, I fully agree with you. So in fact, we are trying to improve on this, and we are enlarging the fraction. So this is a big step forward already, from 10% to 30%. I think it's a really big step forward in this direction. And the plan, of course, is to release 100%. It won't be tomorrow. It will take some time, and for sure by the end of when the observatory will be over, which I hope never, but we will do that. So
there's a problem with that
I
argument.
mean, okay.
So I think it's not just a matter of style, of course. I think publishing data at a level that a collaboration feels comfortable with is a lot of work. You also and so that also costs money. I think so. One of the big differences in astronomy, when we run an observatory, a satellite or so, that you are essentially funded also to publish the data. And often the big experiments like IceCube or Auger maybe are not funded specifically to make the data public. The funding agencies want us to make data public, but they're not. Yeah, but they don't give us the resources to do it quickly. So I think that's a problem. It goes deeper. You know, we often, with these collaborations, like Auger is a very large collaboration, IceCube too, but people are actually working on the project. So you need to also create incentives. You're not paying people to full-time just do service work. You share it among the collaboration. So it's also a collaborative model, which is different. I think in the future, though, we should be moving to the observatory model, where the observatory, in a sense, is 100% funded to create the data and then, with some proprietary time, make sure that the people are rewarded too, but eventually on a short time scale, release the data. But it requires a entirely different model. You can't just request it because it's just not possible. Specifically in IceCube, let me just say how we do it in IceCube. We release it every few years. I mean, but then we release essentially everything. So not the raw data because it's also too much effort to go through, but essentially every neutrino with an energy estimator and with coordinates that we have detected. But we are not doing it instantly because it's also just we can't maintain it.
I mean, this is the point.
But I don't understand. One thing I don't understand in all the discussion with 30%, you could go to 80%, right? I mean, it wouldn't cost you anything extra because you're already running through the data. Once you fix the calibration for 10% or 30%, you must have the calibration for all of the data. I mean, you don't update it every day, but you're not only updating it every 10 years either. So why 30%? Why not 80? Is it just the incentive argument? Because I don't think it's the cost in this case.
I mean, it's not. It's a combination of things. I mean, keep in mind that we are releasing more than just information like. So we are releasing also raw data. We are releasing the traces, SD traces. I mean, we are releasing for each FD pixel. We are giving the integral charge, like the diaphragm. So we are releasing more basic information, more than just giving individual information, energy, direction of individual cosmic rays. And so our plan is a little, and we are releasing also atmospheric data, 100% of the atmospheric data, something. So we are a process that we have started and we are doing progressively. I have to say that in the collaboration has a different opinion. So we are a huge sociological body, as in your case. And so there are different opinions, and also people coming from, I don't know, particle communities have a different opinion that people coming from astrophysics, more oriented community. So it's not easy. So I think we are on the good track because really, which is not really releasing just a few information, but releasing the bulk of information. And I don't know. So we are happy with this 30% so far. Maybe in future we will increase, and it's a huge effort. I agree with you. I mean, because there is people dedicated to this task 100% of the time, and it's not supposed to be paid for that. So we are doing it within the collaboration. We are not giving this job to somebody else outside of the collaboration.
So I guess the third community with the closed data is the very high energy gamma ray one. So I agree with all the challenges that you did mention, with especially from the collaboration point of view. You have this one PhD student for whom the open data is the duty to put even the public thing. Then she quits. Then there is then there is no continuation. So that's an additional challenge to what you listed. And and now with CTAO, of course, when we want to make the first data challenge public, then it's exactly about this documentation that you mentioned. The documentation has to be good enough so that, somebody from the radio community will come and analyze our data based on that documentation and doesn't think that, this is nonsense, I don't get it. Because you want it to be attractive. So the documentation and the instructions have to be really good.
And people don't read documentation, which is really annoying. Can I very quickly just respond, but really, really quickly into that? Just I get all of what you're saying about, it's interesting what you're saying about the cost, and you're saying PhD student, because from the astrophysics point of view, we propose a mission and you form a collaboration and you have elements in there. And we say, archiving data center, making the data public, that's a costed element. So it's not like a PhD student or a couple of people who shouldn't be doing that jobs. It is and I'm a bit surprised actually, if that's the way it goes. And I think that maybe a solution here is that the approach is that you cost that in right from the start. So you have it as a specific work package where there is people whose job it is. And I don't know what that does to your cost scales and so on. But yeah, I can see why it would be a challenge if it's kind of done as an afterthought, kind of, or unbudgeted thought.
This is exactly happening. I mean, you take Hess and Magic. I don't think they have released their data, but CTAO will, because it's from the beginning set up. as a in you know one has learned from sort of this, and when you build something big, you take this into account. I think Auger and IceCube are still sort of old school experiment, but I'm also one of the sort of leaders of IceCube Gen 2, and we are discussing which of the models is the right one. It has to fit the funding agency. I mean, can you afford it in the end, and so on. So it's, in the sense that these collaborations are also run, it's cheap labor. I mean, it's, it's a way to organize an international collaboration also, where you simply organize the work. It's very difficult to say a priori we all have to go to this, but I think it's happening where we can.
Yeah, so I think this is all a really good discussion, and I think there's going to be a lot more fighting over this. Just to open it up to other panel members, what do you two want from everyone else? Or anyone, what do you all want from either the other wavelengths or the gravitational wave community, from the LVK or from Lisa? What do you want?
Yeah, it's more on the gravitational wave side that sometimes we ask for more specific information. For example, the alert with inclination angle. This is something that could be very useful. Info about the masses. The answer we have is that those values are not precise. There are huge errors, so it's useless that we send it out with the alert, because at the alert time they are not precise, and so maybe it would be counterproductive to send them out, because we can make wrong decisions based on that. Well, in my opinion, even if the errors are large, send it out with the large errors, and we take and we made it. Yeah, and also if you say they are uncertain, okay, fine, but there are some information like those ones that are important. The inclination angle, for example, is important for us to understand if we are going more towards a kilonova and which wavelengths to serve and to go, or if we go for an orphan afterglow, maybe if it is not so far away from the on-axis part. This is very important information. So I think we are not so, from our optical community, not so interested in the data of the gravitational wave themselves, even if some cases yes, but more what is released in the alerts that is of interest.
I guess along these lines then, so part of the difficulty has been sort of coordinating multi-wavelength or coordinating follow-up observations among other observatories. And there's always concerns about, of course, we talk about data propriety and stuff, but also about everyone wants it, get on top of the highest probability regions, that sort of thing. Can you imagine a way forward where everyone works together more?
Okay, so they're trying something in also in the US, but I take the case of Europe. What happened after the 17017 for I speaking about the optical near infrared part. In fact, there was a big change of way of working that was a lot pushed by ISO. ISO didn't want to manage the fact of having 10 different groups triggering their instruments, and with highest priority, so they didn't know what to serve first, why, and it was a mess. And so they strongly encourage the community to join together, and this is what we do, and this is what it is, the engraved collaboration that it is, and it's still going on till the end of 2004 to follow up, to look for characterization of counterparts of BNS event and BNS black hole event, neutron star black hole event from detected by LIGO Virgo. So we had the known really useful to date, in fact, this is not only limited to the use of ISO telescopes, because since we all join together within the collaborations, there are also all different people having access to other facilities. So to smaller telescope but with large field of view and so on. And so the fact that then we are all part of the same collaboration makes that the information circulate quite quickly, and we for an event, for example, that was happening in the past, then a bit retracted, but we organize ourselves in sense with small telescope. We will follow these and these regions. So you're following this, you're following that one, and then we use VLT for these specific targets and so on. So the fact of joining for one facility made, in fact, a reaction chain that I think was very effective in consolidating the way of working in the community. I must say that there are a couple of groups that still wanted to stay out, and they are out because they didn't want to join. That's their choice. But that's
Yeah, that sounds really promising. Is there any, just want to make sure.
So this is super cool. Actually, I would like to raise 2 points actually regarding the first one you raised before about the gravitational wave, and from my point of view is quite straightforward. It's very basic. I need a good localization. That's it. That's the only thing I need, and I think that we cannot do anything. So we have that, and that's it. So that's the first point. The second point is that I'm a son of my generation, I would say. So I love to collaborate with people, and I really think that we should do that way more than we are doing. Unfortunately, for the radio perspective, we are like 3 or 4 people doing that continuously. Then when there is 1708, 1708, everyone that do radio is doing also gravitational waves immediately. But do continuously, we are like 3 and 4 or 4. And it's not a community like the optical one. So it's harder to collaborate in this sense, yes.
Any comments from the audience? Anyone want to say anything?
Thanks, that's really great. It's really encouraging. I think this idea of engrave should be extended to every other wavelength and every other messenger. So what can we do to do that? What did you do to put into place engrave?
so. In fact, you should threaten people because, in fact, they threaten people in the sense that ISO said, or you go like that, or you simply don't have time. We will manage. So it was not said so explicitly, but almost. We will manage the observation, and that's it. You're out. So this wasn't said so explicitly. Of course, ISO would say that never said this, and it's true. But it was understood that it was like that. Then, as organization, we had 2 parts. So we have a governing council that, in fact, was made by the PIs, let's say, of the groups that were proposing before the engrave creation. So in this way, you have each group that was kind of well represented within the collaboration to take decisions and so on. And then we have a kind of a committee that is more, it's called executive committee, that is more on people that we really be in the first line in coordinating the observation when something happened. So those are the people that we decide that let's go to the target, let's go to this one with this instrument or with these others and so on, and coordinate the effort really of the observation more practically. Yeah.
Sorry. When engrave, when you're talking about this coordination, this is for searching the whole gravitational wave banana, or for looking at specific counterparts that have been found by independent wide field surveys?
So at ISO, you look for promising counterparts, unless you have very small regions, so you can go with the VLT also for some fainter galaxies, things like that. But since we gather the entire communities, or a huge part of the community, then the consequence was that there was also a coordination in running the observation from smaller telescope scanning the entire error region. But this, of course, is not engraved at the side, but that can say, yes, you observe this one, you observe that one. But let's say that autonomously this took place in a sense, because we knew each other a bit better, we trust each other more, and we knew that we were there for the same purpose and that nobody would have picked the data of the others. I don't know. So naturally it came like that. We also organize, maybe also Natalie, we organize different workshops to make the people together and I mean, put faces on names and start and be able to work together, and also to form people to the work we have to do. We organize data like fake alerts, and we do the procedure. This was very fun. I think the young people appreciated a lot also. So it all makes building a community that works well together, let's say. So we hope that they will go on and can be useful. We have a sort of similar things also at ESO to follow up gamma ray burst. And again, a bit forced in the sense that when we saw that there were proposals that were not going through anymore to ESO with when we were different separate group to ask for, we joined each other, and in fact it went through successfully. And we also made ESO, we convinced ESO to give us also large time that before was not possible for target of opportunity observations. So the fact of being a big community and not single group also has some advantages when you then talk with the observatory and so on. So it's a good situation now in the European community for the optical infrared follow-up. We all work together, and it wasn't like that 10 years ago. It's really a new thing.
So it's kind of almost a top-down thing. So it needs maybe the observatory to say, hey, look, right, guys, please collaborate. Because I mean, we have this problem with XMM. I mean, I don't know how with Swift, but yeah, there's like TOOs that are there for 3 years. You're allowed to, and different people have got different cases why they need to observe that specific gravitational wave event, for instance. And yeah, it's first come, first served. Basically, it's the first one that's quick enough to send an email to Norbert, and then he'll give it to them. And I think that's, in some respect, a little bit unfair.
The other consequence of the thing is that also we are now, of course, it's not mandatory, but as in Engrave, as in Stargate, that is the collaboration for the follow-up of gamma ray burst, we also then propose to JWST or, I don't know, ALMA or others, radio facilities, for example, together. Of course, this is not, I mean, you can be in the collaboration even if then you do your own GWC proposal, because it was not, I mean, in the rules that we set up at the beginning to be in the collaboration. But it has also it had also this effect of making people together, also to propose to other facilities external to ESO. And of course, then we compete there with other groups also from US or other, but this was also not happening before. It's and it's going on now.
So I know this is more topic, more conversation, but I think because we've been very LVK focused, I also want to give a chance to the audience members, especially Lisa and PTA folks. What do you want to see? Is there anything you want from the electromagnetic or the multi-messenger folks up here? Lisa, PTA people, is there anything you want?
In the LISA community, right, the multi-messenger, the electromagnetic part is already ongoing. If you want to be observed, right, the counterparts, you can already do that as long as you search for binaries that are less than 2 minutes orbital period. And I think we are still not organized, maybe what can be the instruments, that we can propose to ESO or to someone else. to follow up then once we have LISA observations. So I don't know how to do that. We don't have maybe, especially on the low mass side, we don't have enough people to galvanize the community. Maybe on the supermassive black holes, it's much more developed. I don't know, do you have any advice on that?
You've just forced a bunch of neutron star people to think about supermassive black holes.
You're asking essentially how the EM community working with LISA can be preparing the next generation of ground facilities to support, especially the non-SMBHs, the lower end ones. And this is kind of outside of my because sorry, from a space point of view, I mean, obviously the overhead times are a lot longer. So for planning stuff that's going to do follow-up of LISA stuff in space, we kind of need to be doing that now, or preferably 3 years ago, which has been happening. But you're right, it's all focused on the high mass stuff, really. Doing things on the ground is not something I've got any experience of. So I don't know if anyone here has proposed to build something on the ground for. Yeah.
I think that the problem that we have with LISA is more that from what I understood, your prediction are very different. Very, I don't know. It's like we don't know exactly what are the specifications that the instrument should have. It's what are the characteristics of the electromagnetic counterparts that you are supposed to produce. So from what I'm hearing in different conferences or different workshops, people say there are some electromagnetic counterparts, others no. There will be as bright as that, or in other cases, super faint and undetectable. It's I think that maybe internally, but I don't know if it is possible, because this is not clear to me. But it would be nice to have to present at least some robust prediction for so as to serve as basis for to then set up the electromagnetic follow-up and understand if we have already the instruments that we needed, or we have to build something specific or something like that.
And maybe just to be a bit more precise, do you think, so we have 10 years now to LISA, do you think we are already late in case we need something new or
Yes.
something? Okay, sorry.
a bit, but so to really build something from zero, unless it is a small telescope, yes. But you are not late at all to prepare the observational strategy, the synergy that they may have. This is not late at all. This is exactly the right time to do it.
All right, so I think we're almost, it's almost lunchtime, but we've got, let's say, 2 more comments.
Yeah, so even though there are like uncertainties and assumptions that need to be, made in the modeling of electromagnetic counterparts, I would say that the look for periodicities in the light curves through photometry, so like ZDF or Vera Rubin, are very robust predictions that we can already, probe, because we already have the instruments. We just need it would be ideal for Vera Rubin to run for longer than 10 years, for instance. So that's, I would say, more easier to get. And then from the space perspective, then I think we lack a lot of physics, at least in the modeling, to make a realistic prediction of, to ask you questions about how do I observe this?
I think we had just one last comment by Natalie.
It's actually just to continue exactly what you were just saying. But I think at least it's slightly different to things that are LVK, because you can prepare for this. You can find out your binaries, you can look for them in the data, and you can be looking for them now. So there's the external data component of the LISA ground segment, which I think some of this should be part of. There should be catalogs being built of the sources that could potentially be LISA sources, because then we're ready to go. We're ready. We can hit the ground running, and there are quite a few people doing that, but the coordinated effort is probably lacking for the moment, as far as I'm concerned. But yeah, the same thing for the white dwarfs. I think that there should be this coordinated effort to look for these things and to fully exploit the Gaia data, because I heard what you said. But yeah, there's a lot could be done, and there is kind of framework built into LISA for doing that, and we should exploit it a bit further.
I think a lot of people want to say a lot of things, I guess, but let's go have lunch now, I would say. And yeah, go eat. I don't know if anything else.